When you're working with programs from the terminal or a command line interface, when you start a program, the command that you give to begin that program is given some arguments. And in this video, we're going to look at how we can access those command line interface arguments from a Python program. This is easiest to understand by diving right into an example. So I'm going to go ahead and set up a new file, and I'm going to use my lessons directory and set up a file named ls29 arguments. I'll call this CLI args.py. Right? So in this course, we're working in the lessons directory or the lessons package in Python, and I've just arbitrarily chosen a module name of ls29_CLI_args. And let's just give a very quick demonstration of how this works, and then we'll try writing a sample program to make use of this concept to show you how it's commonly used in the real world. So we can access command line arguments by importing the system module, and the system module gives us access to a variety of things, but importantly the argument values that our program begins with. So let's go ahead and just print out sys.argv, right? And argv is going to be a list of string values that are the arguments that our command line program was begun with. All right, so I'm going to open up a new terminal. And from my terminal, I'm going to run this Python program as a module. So python-m, and then because I created this in my lessons directory or folder, we're using the lessons package, and then .ls29_CLI_args. And notice this very long path, and yours is going to be different than mine. So we've got a list being printed out, and there's a single string in that list. And this is, the location or the path on my computer's hard drive to the file that we're working in. Notice that here, lessons ls29CLI_args is the file that we're working in. So by default, when you begin a program from the command line, and specifically a Python program, the very first argument or the very first string that's being passed to sys.argv is the file that is running, or the program that is running. So let's give a more interesting demonstration here and try this with some additional arguments. So I might use an argument like 1, 2, and 3 with spaces separating them, right? And what you'll notice is when I began this program, here I'm saying I want the Python interpreter. This is a program that implements the Python programming language to run such that we're using the module mode, and the module that I want you to run is the module lessons.ls29_CLI_args, right? And that corresponds to the file that we're working in and that we're writing our program in. And then the important three arguments that we're seeing next are the string 1. And if I label these with some indices, this is 0 effectively, but you can see that this is actually a file name, not the exact module. And then the second argument, or the argument at index 2 and the argument at index 3. And notice that this list now contains those 3 additional arguments that we began our program with. So this is going to give us a means for starting a program and passing in some information as soon as the program runs. And we're passing this in as the user of this program from outside of the program to impact the behavior or the running mode of how this program operates. And so you might use this to say, give a file name to your program that you want your program to process some file, so that you can control which file your program is targeting and build your program to work generically such that it can work with any different file. And that's what we're going to do in this video. We're going to create a program that can search any file for any search term, and we'll print out lines that match. Right, but before we get into that demonstration, let me just say a few more things about this sys.argv value. So this is a type list. So if we wanted to, we could say import from typings, import list, and from typing, it's not plural, import list. And from here we can say args is a list of strings, and just to prove to you that the type of sys.argv is a list of strings, we can see that in fact that is the correct type here. If we wanted to, we can print the length of args, and this will commonly be used if you want your program, we want some program to be run with a specific number of arguments from the command line, we can test the length. And so remember, this is going to include the name of the file that the program was authored in, as well as any subsequent argument. So this will be at least 1, and then 1 plus however many other arguments we want our program to be able to make use of. We can access individual arguments. So we can print args and then 1 for the first user provided argument and args 2 for the second user provided argument. All right. So if we save this program and then I try running this again, Python m lessons.ls29 underscore CLI args, and then I give arguments like foo and bar as arbitrary values. Notice that the length of the arguments is 3, 1, 2, and then the very first one at index 0 is the path to the file that we're actually running as a program. And then what prints next is when we access the argument with index 1, that's going to be foo and bar. When you're working at the command line and you want to make use of a multi-word argument. So for example, we wanted a phrase here such as hello world. If you put double quotes around an argument, notice that we can treat that as a single string. So by default, if we don't provide any quotes to our arguments when we go to run this program from our command line, each individual word separated by a space will be an individual argument. However, if we wanted to have, hello world foo, we can additionally have arguments which are strings made up of many words by putting quotes around it, right? And you could do this with a single argument as well. I could have just had quote, or double quote around foo, and that would have worked the same, right? But notice if I now had foo hello again, notice that when we print arguments at index 1, that's going to result in hello or foo hello again, and print arguments at index 2 is hello world foo, right? Because all of this is being stored at index 1 and all of this is being stored at index 2. There are more complex rules around escaping or quoting when we're working with command line arguments that are a little bit beyond our scope for this video. All right, so now that we've introduced the fundamental concept of arguments that we can pass into our program from the command line interface, how might this actually be used in a real program? Well, let's try working through an example program together. And what we're going to do is sort of jot down some notes on what we want this program to ultimately do. So we want to be able to run our program as a module with 2 command line arguments. And the first argument will be the name of the file to search. And the second argument will be the search term we're looking for. And what we're going to do is print out all lines containing the search term and the total number of matches, right? Okay, so we've got our problem that we're trying to solve specified here. So maybe we want to make this a little bit more real by adding some scaffolding around our program. So because we want this to run as a module, we should go ahead and set up our idiom for the main function. So I'm going to go ahead and just below here say def main returns none, and the doc comment will be entry point of program run as module. And I'm going to just use the ellipsis, the triple ellipsis here, which is valid Python syntax. That just means there's more to come, but this will ultimately result in no operation here. And this is fine because this function returns none. It's a procedure. So the fact that we don't have a return statement means this is a valid function skeleton as is, right? We know the other part of our idiom for a function or a program that runs from the command line is we have an if statement. If the name of this module, when this is evaluated, is equal to main, that means it was run, this particular script was run as a module, as opposed to being imported from some other place. We'll go ahead and start the main function. All right. Cool. So we've got our idiom set up, and now we want to just sort of keep making a little bit of headway into the problem we're actually trying to solve with this program. So what are our steps here? Well, we want to be able to run this program with 2 command line arguments. Well, we should probably check and have some function that reads our arguments and gives us back maybe a dictionary of the 2 arguments that we're looking for, which would be the name of the file to search and the search term. All right, so I'm going to go ahead and scaffold out a function that might do something such as that. Def read args, and it'll be a parameterless function, but it's going to return a dictionary from string to string. Right? I'm going to need to import dictionary from typing as well. Right? We're going to make this a just a skeleton for now, and it's going to return empty dictionary. So this is an empty dictionary literal, but we should go ahead and make a comment on what it is we're trying to accomplish here. So I'm going to go ahead and add my doc string here, and this is going to say check for valid CLI arguments, command line interface arguments, and return them in a dictionary. If we wanted to be more specific about this, we could say what exact keys that are going to be associated with each argument. We'll use maybe file path for the first argument and the keyword we're searching for the second. Again, the point of this program is we want to be able to run this program, give it 2 input arguments. One's going to be the file name and one's going to be the search term we're looking for. And it's going to read through the file, and each line that contains whatever search term we're looking for, it's going to print that out and then print up the total at the very end. Right? So the first thing we should probably do, actually, before we dig into the details here, let's go ahead and add a little bit more of a framework around where we're going with this program. So I might have my args is going to be a dictionary of string to string, and it's going to be the result of read args. Right? So now that we have our arguments, we should just maybe print them out to make sure that we are making progress. All right, so when we run our program, if we were to run it right now, we would see an empty dictionary printed. And we could, before testing that out, let's just go ahead and complete the implementation of read args. So we need to check for valid command line interface arguments. We can test the list. If we know that this program needs at least 2, or it needs exactly 2 arguments, we want the file name and the search term, then we can check to be sure that system.argv has a length of 3, because remember that is also going to include the very first argument, index 0, is the file name of the program we're running. So we can say if the length of sys.argv is not equal to 3, then what we'll do is print a message that says usage and Python m lessons.ls29 CLI args, and we'll do file and keyword, right? And then what we're going to do is exit our program. So the exit function is a built-in to Python, and what we'll do is it will quit your program at that point and exit so that nothing else happens. And we want this to happen in this case because we're trying to check to be sure that the person who ran this program actually gave us the arguments that we expected this program to need. And what we're saying in this line here, and is common in command line programs, is if you run a program in the wrong way, it's going to print out a message that says, hey, here's how you should use this. And the intent is that you'll see these 2 arguments and say, oh, okay, I need to give it a file and a keyword. All right. The next thing we'll do is we'll just return a dictionary. So we're not even going to set up a variable for this dictionary. We'll just go ahead and return a dictionary where the first key that we'll set up is the file path, and we'll give that a value of sys.argv index 1. And the keyword that we're searching for will be sys.argv2, right? And we can go ahead and safely index this arguments list with the indices 1 and 2, because we'd previously checked to make sure that there was exactly 3. And if there wasn't, then we would exit the program and we wouldn't get to this point. As a reminder, this is a dictionary literal. So building this dictionary object on the fly, and we're giving it 2 keys and 2 associated values. So one key is the file path. That's the first argument. The next is the keyword. That's the second argument. All right. So at this point, we should actually be able to run our program and see what arguments are passed in. And if we don't pass exactly 2 arguments, we should exit the program. So let's try this out. I'm going to just leave this particular function up on the screen while I'm working through this example. All right, so I try running Python. Actually, I've still got this. I don't have it in my history. So Python m lessons.ls29 CLI args. And I'm going to run this without any additional command line arguments. And notice that because when we reached this point of calling the readargs function and seeing that the length was not equal to 3, the length would have been equal to 1. It would have been the path of the file that we were running. We printed out this usage line, and then we exited our program. Notice nothing else happened after that. So I could try the single file. So I might try a file such as I've got a data directory in my workspace, and in that data directory, I have a shakespeare.txt file. So I might say data shakespeare.txt. And notice that it's still telling us the usage wasn't correct because we didn't give it exactly 3 arguments. So what is the word we're going to search for? Maybe the word thou. Maybe we're searching for how many times the word thou occurred in this program. All right, and so notice that this time we didn't get the usage line printed out. This was run correctly based on our readargs function implementation. And what printed out was a dictionary where the key file path is associated with data shakespeare.txt, which notice that was, here's the module we're running. And then the first argument was data/shakespeare.txt. So that's the first, that's what's associated with file path because of this line right here as we were returning a dictionary, literal. And then the keyword that we're going to be searching for is thou. Okay. So we've now got a program that, and if we wanted to try this to be sure that if we tried, some other third argument and we gave too many arguments to the program, it would exit out and give us the usage as well, right? But notice that we can pass different things here. So if I wanted to search for how many times Romeo came up in this file, or one of the fun, interesting things we might do is we'll be able to search our own text. So I could search for the lessons directory /ls29 CLI args.py, and maybe I'm looking for how many times the return keyword appeared in my program. We haven't implemented the searching functionality yet, but I want to point out that what we're able to do is we're able to run our program and provide different inputs to the program as soon as it runs via these arguments. And this is a big win because notice how much easier it is to try this program again with these inputs that we're providing than if we were to ask the user as the program's running, use that input function that you've seen earlier and ask the user to type it in each time the program runs individually, or to what we would call hard code these values into string literals or even constants in our program and have to change our program between runs. Notice this program isn't changing, but we're able to provide different inputs. So I could provide how many times are we searching for the def keyword, right? And so by using system command line arguments like we are here, we're able to write programs that as soon as you run the program, you're able to give it those inputs as part of the beginning or the initialization of that program itself. All right. And this is common throughout every other programming language where you're working at the command line. You'll see it in many other cases in your programming career. It's very, very handy for writing useful programs. So to the end of writing a useful program, let's continue doing that right now. So we've got our arguments, and now what we're going to try and search for are words that in this file that match our arguments. So we can, we've got this first set of comments down. We've got these 2 command line arguments. Now we want to print out all lines containing the search term and the total number of matches. Well, this is actually a pretty complex sentence. When we think about print out all the lines containing the search term and the total number of matches, I've skipped a step here, right? We haven't figured out, well, how do we actually open the file and search the file for all the lines that match? So before we can print things, we probably need to actually search a file. And so I might go ahead and set up a definition for search file. And we want to give this function 2 inputs or 2 parameters, which is going to be the file path that we're searching for, and that's going to be a string, and we want to give it a keyword that we're searching for, which is going to be a string as well. And what is this search going to return? Well, maybe it returns a list of all the lines of the file that we're going to be searching that contain the keyword. So it would return a list of string values, right? And let's just make this a skeleton function for now, where we have a doc comment and we're going to say open file path reads, opens file path, reads each line and returns a list of lines containing with keyword. And that's going off my line here. It reads opens and reads each line and reads file path, returns a line. I've shortened this doc string comments just to be able to fit without scrolling on my screen. Feel free to describe this function however you'd like. And to the end of making this a valid skeleton function, maybe we go ahead and set up a matches list of strings that's initially empty and we return matches, right? So we still have more work to do here, right? So we're using some wishful thinking. We need to implement the algorithm that searches through each of our lines, and we'll do that in just a moment, right? So how can we extend our program such that after we check that you gave the program the correct input arguments, now we go and call the search file function, right? So up in my main function, why don't I say, okay, I want to store my matches or my results. Say, I'll call it results, which is going to be a list of strings. So these are going to be the matching lines. And we want to call the search file function that we just defined down below. So what is the file path we're going to be searching? Well, when we began this program, the first thing that happened was we called this read_args function, and it returned to us a dictionary that contained the key file path. So we're going to say args file path is going to be the path that we're searching, and the keyword will be args keyword, right? Notice that because this was a dictionary, we're able to read, these keys directly from them, and they will have been initialized in the previous step, right? And so maybe after this, we just print the length of results as sort of an intermediary next step as we're working towards our goal of printing all of the lines. So I'm going to just say print length of results, right? Great. So now we've expanded our main function, and notice the main function kind of gives the overarching steps that our program's following. We're reading our arguments, and then we're searching our file, and then we get our results, which are our matching lines, right? So let's go back down and try and implement search file now, once we've got this working. So the first thing we actually might do before we begin working on search file is, why don't I go ahead and run this module one more time. So Python lessons.ls29 CLI args, and then our first argument will be data Shakespeare.txt, and maybe the word we're searching for is thou. All right, and we see 0 printed. That means this program ran successfully. The length of the results was 0, and this makes sense because the search file function is currently a skeleton function that returns an empty list, right? We know we have more work to do, but what we've convinced ourselves of at this point is we don't have any syntax errors. Our program seems to be hooked up. Now we can focus on going and implementing this search file function, right? So down in search file, we want to open and read the file path. So in the previous lesson, we looked at how do we actually read a file line by line by opening it up for reading. And we can do the same thing here. So I might have a file handle that is going to be the result of using the open function, and we're opening the file path for read mode. And I'm just going to leave that as a string literal for now. I probably should extract that out as a named constant, but I'm just going to leave it. And the encoding is going to be UTF-8, right? And so this is a special type of argument that just says the type of file encoding that we might be using, and UTF-8 is by today's standards the most widely accepted. Right? It's just a way of encoding a file for reading that can have characters from many different languages, including Japanese, Chinese, hiragana, katakana, emoji. All those things can be stored in a UTF-8 file format. What we also looked at in the previous video is anytime you open a file, you need to be sure to remember to close it out of good practice. So file handle dot close. All right. Oops, and I misspelled my variable name. Okay. So we are opening this file that we're passing in, and notice that nowhere in this program are we committing to the file that we're reading, like we did in the previous lesson where we looked at file reading. Here, we're able to say from the outside, what is the name of the file that we want this program to read, right? And once we have a file handle, we can use the for in syntax to iterate through each line when we're reading a plain text file. So we can say for line in file handle, and inside of this for in loop, what we can do is we want to test and see, does this line contain the keyword that we're searching for? Now, when you're searching for whether a string has some other string in it, you can use in Python the built-in in syntax, which is pretty handy. And I'm going to do that here to contrast this with the for line in, because even though this is the same keyword, it means very different things. So I'm going to say if the keyword is in file, the line we're looking at. So if keyword is in the line we're looking at, then what we're going to do is say matches.append the line. All right. So let's break down this particular line of code right here. If keyword in line. So notice that we're not using a for here. When we're using the in keyword and we're testing for one string's existence in some other string, this is going to cause a little algorithm to search whether or not the characters of keyword in the exact order and right next to each other are contained in the line that we're searching for. So if we're looking for thou is going to ultimately be what our keyword is in one run, then it's going to search for each line, look for the word thou or the characters thou subsequently following one another. And if it can find that, as soon as it can find that, this would evaluate to true. So this is a Boolean operator. The in operator is Boolean here. This in keyword is saying, this is a special use that's trying to say for each line in the file handle sequence. And so this is going to pull out each line individually, and it means something else, right? So, and that's okay. It's context dependent, and that's okay. There are other ways of testing whether or not keyword is in line. Just to show you one other one really quickly, we could say line.index keyword. So this is a method of a string, and this would return to us the index that it found a keyword at, or -1 if it didn't find anything at all. So if we said if that's greater than or equal to 0, we would know that a match was found, right? But since we don't actually need that index, and this doesn't read quite as naturally, I'm going to leave it with the initial implementation that we saw earlier. All right, so if keyword is in line, then we append this matched line to the matches file. Sorry, to the matches list. And ultimately, once we're done with that loop, so if that keyword was not found in the line, we don't do anything. We just allow Python to move on to the next line by iterating through this for loop. Once we've searched through the entire file, we're going to close that file, and then we're going to return the matches list. And then at that point, we're back in main because we return that list result back to main, and it prints out the length of it. So I'm saving my program, and I'm going to try searching this Shakespeare file one more time for the word thou. And what do you know? There are 6,042 lines in Shakespeare's corpus that use the word thou. To prove to you that this actually works pretty generally, why don't we try searching our lesson 29 CLI args file that we're working in, right? So we're working in lessons directory, and then because we're working with a file path here, which is different from a Python module path. So here I'm saying the directory lessons / ls29 CLI args.py. And then let's say we're searching for the keyword def, right? And if we counted how many times we've seen def in our program, def main, def read args, def search file. So 3 instances of the def keyword. So search for def. And what do you know? There's 3 results. 3 lines contained the keyword def. We could try searching for the return keyword. And there's 4 returns. So where's our other return coming from? So if I were to try using Control F in VS Code and search for return, we have return in a line that is contained in a code comment here. And then we have, and notice that VS Code is saying that there's 4 instances of return. So it looks like our program is working. So yep, there's one more in the file and then one more at line 31, right? So it's kind of neat that we're using a program to read its own contents and evaluate its own contents. And if there were other programs that were in your lessons directory, you could try searching them for specific words, right? The key takeaway here is we've written a program that, notice how easy it is for us to change the search term that we're looking for. Like maybe we're looking for how many times the word list, how many lines contain the word list. And in this particular program, we have 5 lines currently that contain the word list. Right? And if I were to add a comment that's list that has the word list in it and save it and run this program again, oh, that's surprising. Oh, this is case sensitive, so be careful. I got a little excited there and went all caps with my list. And notice there's 6 matches. You could change things to lowercase and for case insensitivity. That's a little bit beyond the scope of what we're doing here. The point that we're trying to illustrate in this example is how to write a program that uses command line arguments in the way that we're seeing. All right, so our last step here is really just to print out all matching lines and the total number of matches. So maybe we have a function named show results, and this takes maybe our matches, which is a list of string values, and this is a procedure. It doesn't actually return anything. And I might just change this comment to a docstring. Print out matching lines and total number of matches, right? And I'm going to use, to make this a skeleton, I'm just going to say dot, dot, dot for now. And let's go hook this up from our main function to be sure that we're actually calling show results. Right, so we've got this definition that's just a skeleton of a procedure. And now for main, rather than doing this, why don't we say show results and results, right? So we're passing this list of strings, which is the list, each line that was matched to the show results function. And we want to print out matching lines. So we say for line and matches, print line. And then we want to print something like outside of this loop. So I might even add some extra space here. Total matches and concatenate the length of matches. Right? So we've got a function at the very end that will be called to print some results. And so if I try running this again, and I scroll up, notice that, so I'm searching the file that we're working in. We are seeing def search file. There's a list that we were searching for, and there's list. So each of the lines that contains the word list is being printed. You'll notice that there's blank lines being printed between each. And the reason for this is when we read in each of our lines, there was a special hidden character at the very end of each line that says, hey, there's a new line that occurs here. This is the end of a line, go down to the next line. But when we print, it's adding another one of those hidden characters that says, hey, move to the next line. So we're getting 2 returns, effectively, or 2 new lines at the end of each line that's being printed. One of the ways that we can avoid this is we can strip that line and remove the white space or the new lines at the end of it, at both ends of it, and try running this again. So we print this out and notice that it's printing and it's removing the tabs at the front of our lines as well as the new lines, and it prints those lines in direct order. All right. So let me see if I can scroll this up just a little bit. All right. Oops. So just to search our program for the keyword list, we see there's 6 lines that match. We could try def again and notice that we see the 4 functions that we now have: def main, def read args, def search file. And because I had, in my data folder, I had previously searched the internet for Shakespeare.txt, or a plain text copy of all of Shakespeare's works. And if we searched for something like Juliet, We could see there's 72 instances of the word Juliet with this exact capitalization. We could see for lines where Juliet's speaking in this particular file, it's JUL period is what it's prefixed with. And we can see all the lines that Juliet says. She apparently has 117 lines. And notice that I'm able to search different files with different words without having to change anything about my program at all, right? I'm just using the exact same program and searching for various things. I could also search for that keyword return and notice that it's finding lines that have return. It's also finding those comments where the word return appears in it. So the point of this video is to introduce the idea of command line arguments. And in Python, the way that you're able to access those command line arguments is through the system.argv property. So you import system, or sys for short, and then argv is going to be a list. And that list that you get back at index 0 is going to be the name of the file that is being run, or the program that's currently running, right? And then the arguments which follow that, or the indices which follow that, are going to be the ones that you type in to your command line interface as you're trying to run your program. It's pretty common to provide some helpful output when you run a program that doesn't have the expected arguments to give some usage information, right? As we're seeing here. And with that, we can write programs like we did in this video, which behave differently based on those arguments. And so this allows us to write programs that you can don't have to change anything about, but allow you to change what file they're working on or some different inputs in a very easy to run way. We structured this program that we ran in a specific way that would allow us to easily test it, right? So if we wanted to test this search file function in some unit tests, we could, because we broke it out into its own function separate from main. And so we tried to intentionally structure this program to have it broken down into meaningful, simple little functions. Right? So this is an example of command line arguments, and now that you can use them, it's much easier to write programs that process various data files and perform the same analysis in different ways. Great work.